Okay, so for the last 2 weeks you've been learning about object-oriented programming. What we're going to do this week is we're going to use those skills in order to create 2 objects of type Finch. So we're actually going to use 2 robots for today's tutorial. So you'll need 2 Finch robots to actually get this to work. And what we're going to do is we're going to create a Finch controls Finch class. So we're going to use one of the robots to control the other one. And what we're going to get it to do is when you tilt the robot forward, the other robot will go forward. When you tilt the controller robot back, the follower robot will go backwards. Also, we can use the controller robot to tilt on the side so that we can turn the follower robot left or right. So to do this, we're creating the class called Finch controls Finch. And if you go inside, get rid of everything, put the import statement on the top that we always use. Remember, this is to import the files that we need, the commands that we need. Remember that there's a capital F over there for Finch. I know some people have forgotten that and gotten into trouble, so don't forget the first F is lowercase, the second F is capital. So we've got our Finch controls Finch class and our main class here, which runs as soon as we create that class. Inside, we're going to create 2 objects. The first object will be of type Finch, just like we always do. We're going to name that controller equals new Finch. And now we're going to create a second object as well, and we're going to call that follower, and it's exactly the same type of object as the controller. So now we have our 2 objects, and what happens is when we connect 2 robots to our computer, the first robot will take on this role and the second will take that role. So if we want to control the first one, we say controller. If we want to control the second one, we say follower. In order to tell them apart, what we can do, we're going to use controller set LED. And what we're doing there is we're saying that the controller's nose, the LED light on it, should be red. That's why we're giving full value to the red, 0 value to the green, and 0 value to the blue. Also, we're going to use the follower robot to set its LED to green. Obviously, red and green is something I chose. You can use whatever color, play with it, and see what you're comfortable with and see what you like. But for now, I'm just going to be boring and use red and green. So now that we've done that, we need to start programming our robots so that they can do something. Before we do, though, it's always good practice to remember that at the end of our program, we need to quit all the Finch items, all the Finch objects, and also exit the system. So before I continue to do anything, what I'm going to do is I'm going to say controller.quit and follower.quit system.exit. And that's pretty standard. We're just putting it now because we shouldn't forget later on to do that. And it's giving us an error there because I put R instead of T. Okay. So now we know that we've created 2 objects. We've set the LEDs to tell them apart. And at the end of the program, they will actually quit and we won't have anything outstanding. So, okay, so what we want to do is we want to control the follower robot using the controller robot, and the way that we end the program or tell it that we've had enough is simply to turn the controller robot upside down. And when we turn it upside down, it will simply tell the program that we are finished. So we need a while statement here saying that while not controller dot is Finch upside down, keep doing something. And this command just basically says that keep checking, and if the controller Finch is not upside down, then keep controlling the follower robot with this. Else, exit this, and that will basically quit. Okay, so in order to control one robot with the other, we're going to need to pass information from one to the other. So we're going to need 3 variables in this case. The first 2 will be double, and I'm going to call them, or we're going to call them accel x for acceleration, and accel y to get the gyrometer basically of the x and y. So one will be controlling the gyroscope, which measures tilt in terms of forwards and backwards, and XLY will basically be recording the accelerometer in terms of left and right tilt. So the idea is that when we tilt the robot forward, the follower robot will go forward. When we tilt the controller robot back, the follower robot will go back. When we tilt the controller robot left, the follower robot will turn left, and when we tilt the controller robot right, then the follower robot will also turn to the right. So we've done our first 2 variables, 2 doubles, accel x and accel y, and the third one is an integer this time. I'm going to name it scaled for wheels. And basically what that is we're going to do some calculations on the x and the y, and what we're going to do is we're going to tell it, should be a semicolon, we're going to tell it there that this is the computed value that will determine the wheel speed. So once we have our 3 variables, then we move on to actually taking the values from our controller robot and passing them on to the follower robot to make it move. Now let's go ahead and get the acceleration from the gyro from the controller robot. And to do that, we use our 2 variables, accel x and accel y. And those are the commands for getting the x acceleration, so basically the tilt for the x-axis and the tilt for the y-axis, the left and right, and that's for the forward and backwards. And it gets stored in here. Now once we have these values, we need to do something to process these values and actually pass them on to the follower robot. Okay, so now we have the accel x and accel y, which is the gyroscope reading, whether we're moving the robot or tilting it to the right, to the left, forwards, or backwards. Now what we want to do is actually figure out which direction the user is trying to move. It's simple to say, okay, based on these accelerations, we can figure it out. However, we want to find out what the primary action is. What we mean by that is if we tilt the robot forward, whenever we tilt it forward or backwards, we're always likely to tilt it to the left or to the right just a little bit, even if we're aiming for a perfect straight. So our program at this point in time will detect both x and y readings. And what we want to do is we want to say to it, well, only figure out and use the main movement that you want. So if we're tilting it forward, ignore that little slight left that's there. And the way to do that is by using an if statement. So I'm going to write down an if statement. Just follow along for me for the moment, and we'll explain it at the end. So if math.abs accel x is bigger than math.abs accelerate y, then do something else. Do something else. Okay, so let's explain that. What we're doing is we're taking the acceleration x and the acceleration y. And like we said, every time we move it, we're going to have acceleration x and y no matter what we do, because we're never going to get a perfect straight or a perfect left or a perfect right. So what we want to do is figure out if x is much bigger or bigger than y, that means the user wants to move forward or backwards, not to the left or to the right. Likewise, if xly is bigger than x, that means that the tilt to the left or to the right is bigger, and therefore the user wants to go left or right, not forwards and backwards. So at this point in time here, whatever code runs here is for moving the robot follower forward or backwards. And likewise, if that's not the case, then we know that moving the robot follower left and right goes there. Now, it's a good idea to always comment on your code. I haven't been putting in comments because that will lengthen the video, but in the PDF that you can download on the MOOC, you will find this code full of comments, so you can follow it along. So now that we've established if the user wants to move forward, backwards, or left and right, like here, let's go ahead and write the code for that. So in order to do that, we're going to use our scaled for wheels variable that we had before, and we are going to use a formula to find what that integer is going to be. The scaled for wheels is basically how fast the wheel is going to move, and we say scaled because this is what happens. When we get the acceleration from the gyroscope, we will get a value from -1.5 to 1.5. So if we tilt the robot back 90 degrees, that will give us a -1.5. If we tilt the robot forwards, it will give us a value of 1.5 maximum if it's all the way forward. Now, if we were to say, right, based on that, if a robot is tilted 1.5 forward, then move the wheel velocity 1.5 as well, the number 1.5 is very, very small. For the gyro, it's the biggest one you can get. For the motors on the wheels, 255 is the biggest that you can get, and that's what we've been using so far. So you can imagine if we only put 1.5 value, then the robot is barely going to move, if at all. So we need to do a conversion here, a scale, to move that maximum 1.5 value to 255, or that 1.2 value of the gyroscope to whatever it is, like 200 or something like that. And the formula that we use to do that is the 255, which is the maximum that the wheels can take, times whatever our acceleration is, and we divide that by 1.5. And one last thing, that scale for wheels is an integer. That can give us a double or something different. So what we need to do is we need to make sure and tell it that whatever that comes out to, turn it into an integer. And the way that we do that is something called casting. We simply put a bracket with int in front of it. And that basically says whatever value you get on the right, it must be converted to an integer. Do that now before you pass it to scaled for wheels. And when that's done, we will then have the value that we need. So we're just going to do the standard follower.set wheel velocities, which we've seen before, and the value of that will be scaled for wheels. So we do that. That's the left and the right wheels sorted. Notice we don't give it time. We don't give 1 or 2 seconds like we do other times. This is because we have that while statement there that's always going to run. So that will happen as long as we move and tilt the robot. So there won't be a 1 or 2 second. It'll just be real time, whatever we choose, until we flip the robot upside down. We will be able to control it. No time. So now that that's done, we can do the same for the left and the right here. So it's very similar. We're going to do scaled for wheels should equals, we cast that, so no matter what happens, it's going to be an integer, and we give it exactly the same formula, so 255 times acceleration, this time of course of y, divided by 1.5, and then follower dot set wheel velocities scaled for wheels, comma, scaled for wheels. The only difference is, other than the XLY of course, that this time we want to turn it. So we don't want the two wheels to be turning together. We want them to be turning the opposite of each other. So we're going to minus that scale for wheels, so that one wheel will be moving in a different direction to the other. Therefore, the Finch robot will turn left or right. And that's our code. So if we run that, that should control the robot. If we do a forward tilt, our follower robot should go forward, a back tilt makes it go back, a left tilt makes it turn left, and a right tilt makes it turn right. Now, before we run that, let's just compile to see if there's any problems. There we go, let's debug that. That's a capital S, it should be a small s. And of course, that should be a C there. And there we go. We've compiled that. Now we can run it and see our robot in action.